Definite integration. As we know, integration has two types. First type we have learned indefinite integration, in which if f of x is a function of x, then its integration is capital F of x plus c, where c is called constant of integration. Such integration is indefinite integration as it contains a constant of integration. As you can see here, this is a function of x and integration is again a function of x. So, and the value of c is not defined. So it's indefinite integration. So in indefinite integration, we have learned the integration of function of x is again a function of x with constant of integration. Now fx is a continuous function on closed interval ab. That means in each value of x between a and b there exists f of x. Such a function f of x is called continuous function. Is integrated from a to b. As x has a lower value a, so a is called lower limit of integration and b is a upper value of x, so b is called upper limit of integration, and this read as integration from a to b f of x dx. As f of x has the integration capital F of x plus c, now we put the upper limit in this integration, so we get f of b plus c, and lower limit in again in integration, so we get f of a plus c, and subtracting them we cancel the constant of integration c, so c is eliminated from here and we get upper value minus lower value, which is a constant. So such a integration is called definite integration. Okay, as you understand, in indefinite integration we get function of x again and constant of integration, but in definite integration, as we use limits of integration and evaluate the value which is a definite or constant, and constant of integration c is eliminated. Evaluate integration from 2 to 3 x square dx. As here 2 and 3 are the given limits of integration, as 2 is the lower limit of integration and 3 is the upper limit of integration. So this is the integration in definite which we have solved in definite integration. As we know, integration is always represented by I. So here I put I as the integration from 2 to 3 x square dx. Now in definite integration we evaluate integration of a function by using standard integration. As here is a power function x square, so its integration will be increases by increasing its index by 1, we get x cube by 3. As we know, as we learn in definition, constant of integration c is eliminated by taking upper value minus lower value, so we don't put here constant of integration. Instead of it, we put the on integration limits. As lower limit is a 2, so we take it is in base, and upper limit is in is a 3, so we put in up index. Okay, so now by putting the value of upper limit first, we get the upper value of integration. Here upper limit is 3, so 3 cube divided by 3 is the upper value, minus again putting lower limit in integration, so we get lower value. As x is equal to 2, so 2 cube divided by 3. Now simplifying this, 3 cube is a 27 by 3 is again 9, minus 2 cube is a 8 divided, actually I read it 27 by 3 minus 8 by 3, so we get simplification as 19 by 3. So you can observe, as if we take indefinite integration of x square, we get the answer x cube by 3 plus c, which is again function of x with constant of integration c. Instead of in definite integration of x square from given limits 2 to 3, we get the value 19 by 3, which is a constant, which is a definite. So this integration is a definite integration and this is an indefinite integration. Now observe, in definite integration the limits are important. As we change the limits, the value of constant or value of integration will be changed. So first define limits, lower limit and upper limit, then take a integration of a function without constant of integration c, and then first put upper limit, so you get upper value of integration, and then lower limit in integration, so you get lower value of integration, and then subtract the upper value and lower value to get definite or constant value, which is a integration of your example. Here I is equal to integration from 2 to 11 1 upon 2x plus 11 days. As these are the limits of integration, so this is an example of definite integration with lower limit 2 and upper limit 11. That means the lower value of x is a 2 and upper value of x is a 11. Now this is a form of 1 upon ax plus b, as has integration in form of log with coefficient 2. We get the integration log of 2x plus 11 divided by 2, and instead of putting plus c, we put integrations limit as lower limit to upper limit 11. Now you can observe here, the in integration you get the term of log and constant. Now by putting upper limit we get upper value, and putting lower limit we get lower value, and then we subtract them. The constant remain as it is in integration. So here 2 is a constant, so now from onwards we take this constant out of this bracket, so we get only term of x on which we put the limits. Okay, so the 2 is in product or is in denominator, so we take it outside, so we get 1 by 2, and in bracket we get the term of x only, that is log of 2x plus 11 with lower limit to upper limit 11. Now putting the upper limit first, as 1 by 2 is a constant, so in bracket we first get the upper value as x is 11. So this term log of 2x plus 11 with x as 11, we get 2 into 11 plus 11, and then put minus sign, and again the in same term of x we put the lower limit of integration, as it is a 2, so we get lower value as log of 2 into 2 plus 11. Now simplifying this we get the constant which we have to evaluate. Now here log of 2 into 11, 22 plus 11, 33 is the upper value of integration, minus lower value of integration will be 2 into 2, 4 plus 11, 15, log of 15. Now simplifying this, we know the rule of log, that is in subtraction we take division of numbers. So log of 33 minus log of 15 is equal to log of 33 by 15, which is our answer. Rule of definite integration. As you understand here, the difference between indefinite integration and definite integration, it is only difference of constant of integration c. Instead of it, in definite integration we use limits of integration, as we use constant of integration is indefinite integration. Now the rules are same here for definite and indefinite, but as we use limits in definite integration, the first rule become now as taking limits from a to b, addition of or subtraction of two terms of x, we take separate integration with its limits, and limits does not change, as we have given limits from a to b. For addition or subtraction of integration, we take same limits for each integration of each term, and then take their addition or subtraction. And in second rule, as we know, constant of integration we always take outside integration. Here we take constant of integration outside integration, and limits does not change, as it we take integration of function of x only.